In this video, we'll be doing topic 1.8 of AP Pre-Calculus. So let's get started. So this topic goes over rational functions and zeros. Alright, so yeah, from topic 1.7, we know that a rational function is two polynomial functions in a fraction, basically. And I didn't go over 1.5, but that was about polynomial inequalities and solving that, either putting it in like a number line or graphing them to find out the intervals that x would be greater than 0 or less than 0 or less than equal to 0. But now this one is going to be on rational functions instead of just polynomials. And so this is telling us that we need to equal the numerator, the polynomial on the top to equal to 0, as well as the polynomial in the denominator to equal to 0, so that we can find the values. When you're solving for 0, we find the values, and that would be the important values. It says more down here. So it says to identify both the zeros and undefined values. That basically means to find the critical values, which is basically just the values on the top and bottom. Let's say, yeah, this one right here, our critical values, we put both the numerator and denominator equal to 0, and then we just solve for all three of them. And then those three would be our critical values. But then we also need to note how one of them could be like a vertical asymptote, which means that it doesn't reach that number. And so yeah, solving for these rational inequalities, we're basically just given the intervals where it would like be greater than or equal to 0 or less than 0, whatever the inequality says. Yeah, we need to make sure the numerator and the denominator and they're equal to 0 so that we can solve them. Yeah, make sure to factor so you can know the critical values. And then we want to create a sign chart, which is that number line where we find numbers in between those critical values to see if they're gonna output a negative or a positive number. That would mean that if it's positive, then it's over 0, negative, and then it's less than 0. Then depending on the inequality, if we're trying to solve for less than 0, then the negative intervals would be our answer, and vice versa. And so number 5 is telling us to be careful to mark the values where h of x is equal to 0. So we never include those values in our solution. That's basically telling us the vertical asymptotes, because the vertical asymptotes, if you're thinking of it in the graph right here, say the vertical asymptote is here, an equation like that, and we're thinking about the intervals greater than 0. So up here, basically, it's never going to touch this number of this vertical asymptote. We never want to include that solution so in our intervals. So we make sure that it's an open parentheses rather than a closed. Closed means including that number. Yeah, you'll see when we get there. But hopefully you understand. Because I don't know if you're watching this video just to learn it, or you're watching this video because you didn't understand what your teacher taught you yet. Number 6, the test values in each interval. Yeah, test the values of each intervals using that number line method and see if they output a positive or a negative. Yeah, and then a positive would mean use the positive the numbers in the positive interval if inequality has a greater than or equal to, and then the negative is less than and less than or equal to. And then number 7, interpret the sign chart to answer the given inequality from the problem. Yeah, and be sure to put your answer in interval notation. And think about the endpoints, which basically means think of it, is it touching a number? Is it going to be an open or closed brackets? Yeah. So let's go with example 1. Also comment down below, would you rather have me solve with a red pen or a black pen or another color? I don't know. So, but I'm going to go with red. We want to equal both the numerator and denominator to 0 and then solve for them. So we got -6 here, +3, and +2. So our critical values, abbreviated to CA, is -6, 3, and 2. And then basically the numbers in the denominator are going to be our vertical asymptotes. Yeah, that's an important step. Number 5, be careful. Make sure you mark those. I'm going to put a star above those numbers that are vertical asymptotes, so I know that I should not include those in our solutions. So we can create our, using the number line method, we can create that here. We want to place those 3 values, so we're going to put 3 there, and then go from least to greatest, of course. This is negative infinity, infinity. You should just know that. So this right here is -6. This is 2, and this is 3. And now between each of those numbers, we want to choose a value. So I'm just going to go with -10. And whenever you can do 0, always do 0, because that's just easy. And 2 to 3, we're going to have to do a decimal there, so we're going to go with 2.5. And then the last one, we're just going to go with 5. And so with each of these values, we want to plug these values back into the equation, but not doing the math, just seeing if like -10 minus 2, is that a positive or a negative? And then we write that. And so -10 minus 2, that's going to be a negative. So the top is a negative over -10 plus 6, which is also a negative. So negative, and then -10 minus 3, that's also going to be a -2. So negative times negative at the denominator. And negative times a negative, that becomes positive. So it's a negative divided by a positive, which becomes negative. So we're going to write negative. You can put a negative sign, but I like to put negative so like I don't get mixed up. And like if I have a negative sign, I might get mixed up with all these negative signs up here. Or just say neg and pause. So 0 minus 2 is equal to -2, so that's a negative. Hopefully you can think of that in your mind, because I think that's just too much to write. And so 0 plus 6, that's a positive, and 0 minus 3 that's a negative. So negative divided by negative, that's going to give us a positive. 2.5 minus 2, we're on to 2.5 now. 2.5 minus 2, that's a positive, divided by 2.5 plus 6, that's positive. 2.5 minus 3, that's going to give us -0.5, so that's a negative. Positive times negative is a negative. Positive divided by negative, that's going to give us a negative. I'm just going to section these out here. Yeah, it's going to be more work than usual. And then lastly, 5 minus 3, that's a positive. Over 5 plus 6, that's a positive. Times positive 5 minus 3. And positive divided by positive is going to give us a positive. And then when we look back at the sign, I'm just going to erase what's up here. We look back at the sign, it says solve for the values of greater than or equal to 0. So we're looking for the positive ones, which is this is positive right here, and this is positive. So then we're using these intervals, and then we also want to make sure that this right here, that's a vertical asymptote, and this right here is also a vertical asymptote. So now I'm going to be writing it up here, our solution. We do not want to include -6. Usually with this sign right here, greater than and equal to, we want to include those values, but because it's a vertical asymptote, there is no x is equal to -6. And then that goes to 2. We can see with this interval right here, I honestly don't even know what that means, but we put it. We do it. 3, don't include 3. That's also a vertical asymptote, because those are the zeros in the denominator. Never want to include those values. And then that goes to infinity right here, positive infinity. So positive infinity, and we never include infinity, so that's an open. Oh, I messed up right there. 2 should be a closed bracket, because that's not a vertical asymptote, and that actually, is included, because that's in the numerator. And so that should be our answer. That is quite a lot. All right, so example number 2 we have here. We do not have our factored form, so we're going to have to factor ourselves. So that's a dot difference of squares, so 2x plus 2. And at the bottom is x plus minus 5. We can see that adds up to negative 10, but multiplies to positive 25, so that's 2 negative 5s. And it's less than 0. So our critical values is going to be positive 2, negative 2, and then 5, positive 5. But that positive 5 is going to be our vertical asymptote because it's in the denominator. And so we want to write the number line. Where we do ignore that the 5 is stated twice. Since it's a vertical asymptote, there's not really a multiplicity. And so we have 3 values here, so 3 lines. Going by least to greatest, negative 2, 2, and 5. So we're going to go with negative 4 here. We're going to go with 0, 3, and 6. I think it's easier if you go like those, like by 5s or something like that. I actually, any number's fine, just like decimals would be harder. So plugging those in, negative 4 minus 2, that's a negative, times negative. Negative 4 minus 5 is negative, times a negative, because that's the same thing. And so positive divided by positive, that's going to give us a positive. Positive reveal. Bruh. I just sectioned that out, because why not? And so 0 minus 2, that's negative, positive, 0 plus 2. 0 minus 5, negative, times negative. This becomes negative. So negative divided by positive, that's a negative. 3 minus 2, that's positive. 3 plus 2, that's positive. Over 3 minus 5, 3 minus 5, so that those are both negatives. And so positive divided by negative, that gives us this is positive. So positive divided by positive, that gives us a positive. Make sure, don't do mistakes like I did. On practice, it's fine. Mistakes are where you learn. And a 6 minus 2, that gives us positive, times 8, which is positive. Oops, I was about to write 8. Oopsies. 6 minus 5, that's a positive, times positive. And that gives us positive right there. And so when we look back at the sign, the intervals that we're trying to solve, that's less than 0. So we're looking for the negatives. And, only this right here is negative. So this interval, well, there's barely any space. We can include these two because they're not the vertical asymptote, but they will only be allowed to be included if this says less than or equal to. And because it only says less than 0, we're not going to include those numbers. But I just wanted to tell you guys that they are not vertical asymptotes. So we're not including, so that's open bracket. So it's negative 2 to 2. And that should be our answer. Or you can write these answers as like this, but I think it's better to do with like a open and close bracket. But you can use like these symbols. So yeah. Okay, moving on to the next problem. So 2 doesn't give us anything, so just ignore that. And then 3 is going to give us positive 3. So our critical values are 3, but that 3 is a vertical asymptote. So we'll just put a star, vertical asymptote, and then let's draw that number line. This is only going to have one value, so that's just going to be quick. 2, so we're going to put 0 here, and then we're going to put a 5. So 2, that's positive. So they're both going to have positive at the top. 0 minus 3, that's negative. 5 minus 3, that's positive. So positive divided by negative. I keep switching around here. I don't know why. Because it's just so quick, I guess. So this is going to give us a negative. This is going to give us a positive. So we're trying to find greater than 0. So we are looking at this interval here. and 3 is a vertical asymptote, but also it doesn't say equal to, so it's just an open at 3 to positive infinity. Okay, this one right here, we can factor that again. So this would go to, this is going to factor out to 4x plus 2 over x plus 5. And so, yeah, that's less than or equal to 0. So the critical values, -2 and -5. And -5 is that vertical asymptote because it's at the bottom. And now we're going to draw that numbered line. 2 values. -5 goes first, -2. We're going to go with -10, -3, and 0. Again, you can use any values, whatever you want. And so, -10 plus 2, that's -8 times a positive. That gives us a negative. -10 plus 5, that's a negative. So that gives us a positive. Negative divided by negative gives us a positive. -3 plus 2, that's a negative. So negative. Yeah, negative times 4, that's a negative. -3 plus 5, that's actually a positive. And so that's going to give us negative. And then 0 plus 2 is 2 times 4, that's a positive. Over positive, so output is positive. And so we're looking for less than or equal to 0. So it's going to be this interval. And -5 is that asymptote here. So we do want to include numbers since it says equal to. We can't include -5. So that's an open at -5. And then -2, we are going to include it, so that's closed. And so that should be the answer. Right here, so we got +1, -2, and then +2. So our critical values here are 1, 2, and -2. And then 2 is the vertical asymptote. So let's create that number line. -2, 1, and 2. We got -5, 0. We're going to have to put decimals 1.5, and then 5. So -5 minus 1, that's a -6, so negative, times, we do want to use this entire thing here. So include that the square. So I'm just going to erase this right here. -5 plus 2 is a negative number, so, and a negative number times a negative number because it's being squared, that's going to give us positive. So I think whenever you have a squaring the negative, well, actually, whenever you have a square, it's always going to be positive, no matter if the x is negative or positive. So that's just going to be positive. And then -5 minus 2, that's a negative. So this results in a positive. Negative divided by negative. 0 minus 1 is negative times positive. 0 minus 2, that's negative. So that also results in a positive. 1 or 1.5. 1.5 minus 1, that's a positive. Times a positive. And then 1.5 minus 2, that's a negative. So that results in a negative. And then 5 minus 1, that's positive, times positive, over 5 minus 2, which is positive 2. So that results in a positive. And then we're looking for greater than or equal to 0. So we're doing the positive interval. So this, and then these two. And then our vertical asymptote is this positive 2 right here. Because -2 is not a vertical asymptote, we can combine these two intervals here instead of separating them. So we can put negative infinity to all the way to 1 right here. 1, that would be a closed bracket. And then U2 is an open bracket because that's the vertical asymptote to positive infinity, and that's our answer. So we're moving on to the next one. This is nothing, the top is nothing. This is +1, so critical values is only 1, but that's going to be our vertical asymptote. Putting that into the line, 1, so let's just put like -2 and 2, plus, because that's 1 is on top, so plus on both of them. Then -2, that's just always a positive since that's a square. So that gives us a positive. And then square, that's positive again. That's also going to give us a positive. Then looking at what we're solving for, less than or equal to 0. They're both positive. None of them are negative, so this one's going to be no solution. No solution. Or none. And our last example is a graph we have here. The graph of the rational function f is shown in the figure above. Use the graph to solve the following inequalities. Okay, so we want to figure out what is less than or equal to 0. So less than or equal to 0 is going to be down here. Let's write these vertical asymptote. That's -3. And this right here is 3, so we're not going to include those values. So, and this right here goes above. This goes above 0, so we have to split this interval into this and this. So then don't include -3 to -1. We're going to include that since we're looking for less than or equal to 0. Then you include 2 and do not include 3 because that's a vertical asymptote. And now we're looking for greater than 0, not greater than or equal to, just greater than 0. So we're going to include this and this. Pay attention to that vertical asymptote. So that's going to be -infinity to -3. Don't include u. Yeah, don't forget about this right here. We're going to include that. No, don't include since we're looking at greater than 0 only. So -1, 2, and then u, 3, don't include, and then to infinity. And now we're looking for greater than or equal to 1. So this is not 0. This is 1, which is that horizontal asymptote there. So y is equal to 1. So greater than and equal to 1. So we can say, so right here, this goes to -infinity. And then right here, that's -3, that vertical asymptote. Not including that. Then u, this equation, 3 to infinity. And that should be our answer. Alright, so that was topic 1.8. And thank you for watching.
Thank you so much.